quick early demo of Banghashat, which is a sort of personal knowledge management second brain type thing. It's mainly based on this paper from 1976. The syntax is based around tags in a way which hopefully reflects real-world usage. That is, the @ symbol is used for entities and hash is used for tags. You see this notation almost everywhere nowadays, including, for example, on Hacker News, where it doesn't actually mean anything in the context of the site. So this tweet would be written in Banghashat like that. You can just add arbitrary text other than tags. It's treated as a comment. So in fact, any text file will pass successfully. You can't really have a syntax error because anything it doesn't understand, it just treats as a comment. Normally an entity would have a long descriptive name with white space and then use brackets. You can use squirrely brackets as well, and as many brackets as you want. For example, if you needed to escape brackets in the name. Obviously you can have as many tags as you want, including this other type of tag called a bang tag, which has no technical distinction from a hashtag, but can be used to express a slightly different type of relationship, like more of a sort of category or type, whereas a hashtag is more of a like attribute or property, like an adjective type relationship. So this paper describes basically a graph database where entities are linked together by relationships. So that the syntax for that in Banghashat is a sort of like YAML or JSON with a colon, and the value of that attribute can be either another entity within the system or text, and you can use brackets again if you would need to use spaces in the value. So the cool thing from this paper is that those labels, as it says, the tags can be arranged into a sort of hierarchy or order and then substituted in place of each other. So for example, in Banghashat, if we said that former NBA player is a subtag of NBA player, is a subtag of basketball player, is a subtag of sports person, then if we search for sports person, we would get Charles Barkley, even though Charles Barkley was in fact tagged as a former NBA player and not as a sports person. So here's a demo of that. So for example, if I ask for Simpsons character, then you can see it pulls back all these entities, even though, for example, Maggie is tagged as Simpsons family rather than Simpsons character, but I've said that Simpsons family is a subtype of Simpsons character. Then obviously the properties can be referenced, JSON style syntax with the object and key. So one of the motivating examples for this was this slightly difficult to model scenario where we want to tag something as a baker, a writer, and skilled, but only skilled as a baker and not skilled as a writer, which is basically impossible to do if you only have one type of tag. So we can model that in this system like this with these two entities. You see that Shrek and Fiona are both tagged as writer, they're both tagged as baker, and they're both tagged as skilled. So those three queries return both entities, but only Shrek is skilled in the context of a writer, and only Fiona is skilled in the context of a baker. So or we can also, just as a demo, I'll show you this hierarchy thing. It can also be used for the any other type of tag. So for example, we can say Bart Simpson is Barto is Bartholomew Jojo Simpson. These are essentially synonyms of each other. And if you want to say something like, we can say Lisa, sister, we get Maggie, brother, we get Bart. But at the moment, we can't say something like sibling to get both of them. But if we add relationships like this and say sister and brother are both subtypes of sibling, then as soon as I save this file, you'll see that now Lisa sibling returns both of those entities because it knows it's allowed to substitute in brother and sister in place of sibling in this query. And these relationships too can be context aware. So you notice on these things we say but we just use Bart and Lisa, but it knows, for example, if I ask for someone, I say, well, look for someone whose brother is Bart Simpson. It finds Lisa and Maggie, even though the actual value of brother for those entities is Bart. It knows that in the context of Simpson's character, Bart means Bart Simpson. And that might be because, for example, in the context of transport, you might want to use BART to be Bay Area Rapid Transit System. Just to show you how that works, if I temporarily just untag Maggie as Simpson's family, then when I save the file, you see that brother Bart Simpson only finds Lisa because it doesn't know that it's allowed to substitute out this Bart as synonymous for Bart Simpson, because Maggie is not said to be part of this tag here. But when I tag her with something which is a subtag of that context and save, then she does match that query. So there are lots of other things I have in plan for. Oh, so sorry, yes. So this can also be used sort of in line here. So if I ask for Homer's salary, it matches both those tags. But if I want to limit it to the context of that, then it only pulls out this value. Another scenario which is quite difficult to model in other systems. So got lots of ideas for future features, but that's it as it exists at the moment.